I've already mentioned this, okay? In the polar system, the pole is like the origin in the rectangular system. The polar axis in the polar system is like the positive x-axis in the rectangular system. So let's kind of set up, we've seen this before, okay? We're going to connect these two systems together. And guess what we're going to use to do it? A right triangle. Okay, so we've got our radius r. Why are we talking? Our radius r, our angle theta. We've got our horizontal part, which is like the x. We've got our vertical part, which is our y. Okay, so this point out here in the rectangular system is the point xy. In the polar system, it's r theta. Okay, in the rectangular system, it's xy. In the polar system, it's r theta. It's the same point. We're just talking about two different systems. All right, so here is what we're going to need to use. We've got a right triangle right here, correct? So x squared plus y squared is equal to the radius squared, r squared. Okay, so we may need to use that. And then we may also need to break it down into our trig relationships. The sine of the angle is equal to the opposite of the hypotenuse, which in this case is y over r. The cosine of the angle is the adjacent over the hypotenuse, in this case x over r. And tangent of the angle is opposite over adjacent, which is y over x. Okay, guess what? This is just like vectors. It's just like vectors, except we've just got the radius in there instead of the magnitude. We've got the radius instead of the magnitude. So nothing has changed, okay? The y value goes with sine. The x value goes with the cosine. The angle goes with the inverse tangent, okay? Exactly the same relationship as vectors, all right? So let's do some converting. If we have the point positive 2, 3 pi over 2, and we want to convert that to its rectangular coordinates, so let me just rewrite that x is equal to r cosine of theta. What is that squeaky noise? Stop. The radius is 2. Cosine of the angle, 3 pi over 2. Don't type that into your calculator. What's the cosine of 3 pi over 2? 0. I'm going to give y'all another quiz on the unit circle if we don't remember this stuff. 2 times 0 is 0. So our y-coordinate is r times the sine of theta. So r is 2, sine of theta. What's the sine of 3 pi over 2? Negative 1. So 2 times negative 1 is negative 2. So in the rectangular system, the point 2, 3 pi over 2 is the point 0, negative 2. Okay. Now that one's an easy one because 3 pi over 2 is on what? The negative negative y-axis. So it should kind of make sense that it's the point 0, 2. Now, what if we're not on an axis? That's not going to be quite as easy. So let's look at example B. X equals r times the cosine of the angle. I want these in exact coordinates. So if you have already forgotten your unit circle, then you need to pull that bad boy out and have it sitting right beside you, because I do not want decimals of this. Okay, the cosine of pi over 3, anybody remember? 1/2. So you would have gotten lucky with that one because it ends up being a whole number, negative 4. The y value, on the other hand, would not. Negative 8 times the sine of pi over 3. What's the sine of pi over 3? Square root of 3 over 2. Square root of 3 over 2. So the y coordinate here would end up being 4 square roots of 3. So the point in the rectangular system is negative 4 negative 4 square roots of 3. Now, take a second to make sure that that makes sense. Think about this point in the polar system. Pi over 3 is in the first quadrant, but we have a negative radius. So that would send us into what quadrant? We're in the first quadrant, we got a negative radius, which shoots us through the pole, puts us in the third quadrant. X's are negative and Y's are negative. Okay? So make sure that the rectangular point makes sense with where the polar point is. Okay? Now, polar to rectangular is the easier conversion. So we're going to practice with that first, and then we'll look at rectangular to polar because that takes a little bit more work.